Okay, let's take a look at Landboard's card, the MAX7219X4. It's a 32-digit display. The card displays 4 rows with 8 characters per row and can display numbers or hexadecimal values, as well as some characters that fit within the 8-segment displays and decimal point. This part of the video shows the card putting up hexadecimal values with a delay between each character, and here's what it shows being put up without a delay. Pretty nice. The card has a 3.3 volt interface to it with a level shifter. It requires 5 volts and 3.3 volts power. The 5 volt drives all the LEDs, and the 3.3 volts is the interface level, and it takes in the clock, the chip select or load signal, and the data in line, and it also drives out the data out line. The form factor is our 95 by 95 millimeter ODAS card format, and it has 4 632 mounting holes on the 4 sides for easily mounting it to other ODAS cards or inside of chassis. The little cable connection at the bottom can be mounted on the back, and that's what's shown here. There's minimal ASCII support. The demo is coded in the Arduino IDE, and let's take a quick look at the code itself. I've linked to the pages, wiki pages for the card itself, the MAX7219X4. With 4 displays and 8 digits per row. It's running on our Arduino in a box. It could be run on any 3.3 volt Arduino, with the caveat that it does require 5 volts for power for the LEDs and 3.3 volts for the signals. That particular card does support 5 volts and 3.3 volts, 5 volts for power if you put 5 volts on the jack coming in. The main library is the LED control.h library. It's a standard Arduino library, and it does support, although the documentation doesn't clearly show it, it does support multiple chips on the chain. It requires hooking up a data in pin. It requires hooking up a clock pin and a chip select pin, and then setting the number of devices. In this case, there's 4 of those 8-digit displays, and then calling the constructor with the pin names and the device count. The delay that's shown in the video is 75 milliseconds. Setup code is very straightforward. In this case, we have a serial debug, but it's not required for it. It does an unshutdown of the displays, and then it sets the intensity to a mid-range value of 8 for all 4 displays. Got the particular segments are also defined if you want to do write to a particular segment, which is required for some characters if you don't like the choice they make or there's no choice. But for numbers, you just use a digit value. I've got a clear display function here in the Arduino code, and that clears all 4 displays, and then the write hex digit will write out a hex digit value, and in this case I'm writing out in a incrementing pattern, as you saw, and I'm just setting that digit to that particular value, and that'll turn that digit on 1 digit at a time. So this is a call to that function that I've created called write hex digit, with the row, column, and the digit value that you want to present. The loop code is pretty straightforward. It goes through and just writes out the characters as hex digits in the rows, and that's about all there is to the code. Pretty straightforward. The first section here writes the screen with the delay time included. The second shows it without delay time, just to show how quick the display is, and then there's a pause between displaying each frame. This could be coded in any computer system, any microprocessor that has enough digital IOs and a library to do that function, or the library could be replaced, of course, or rewritten. It isn't really particularly complicated, although it does have some control registers and such in it that need to be written, as you saw back up here for the clear display function and for the shutdown and set intensity functions. I'm also taking a look at coding this in VHDL so that I can have this be a bus monitor for microprocessor retro computer system kind of projects, in particular FPGA computers that I want to look inside and see what the address and data buses are at a particular point in time. Having the hex displays will be a very nice function for that, but the Arduino code shows the hardware's functioning. If you want more information, you can see our wiki pages for these products, and we have YouTube videos on them as well. We have a store in Tindy where we sell all of our cards. Thanks for watching our video, and if you enjoyed it, don't forget to like, share, and subscribe.